Hi there. Obviously, we're going to have a bit of a different lesson today, seeing as I'm not in the room. I'm actually right now at a training for something called EPICS, which is Engineering Projects in Community Service. Basically, it's a program Purdue University started for their engineering undergraduate students that basically had these students designing and using principles of engineering and design to help basically community organizations, and they expanded it so that it reached high schools. So I'm currently with Miss Paulin and Miss Ernst attending this conference on it, so we can hopefully bring it to Heron and maybe help out some community organizations in the Heron area with your help maybe in the future for you juniors. But here's what we're going to be doing today. So you should have already done your bell work. We're going to have notes to some extent. They're going to be shorter, and they're mostly compiling skills and things you guys learned last week and last semester, so they shouldn't be too bad. But I'm going to walk you through those using this video, and this video hopefully will also be posted to my haiku so you guys can follow along that way. But first I do want to go over just kind of the things you should have discovered using Desmos on Thursday and Friday. So if we look at this graph right here, we can see we have the graph of b to the x essentially, right? And when you looked at the effect of b on this graph, you should have seen that basically any value of b that was greater than 1 should have created an exponential growth graph. You can see all of these graphs that I'm showing you here approach the horizontal asymptote on the left side and approach y equals infinity on the right side. It goes infinitely upward. You should have also seen that if I were to make b a value less than 1, so for example here b is 0.2, here b is 0.8, we have an exponential decay graph, right? On the right side of the graph, the line approaches the horizontal asymptote, and on the left side of the graph, the line approaches infinity. It goes infinitely upward on the left side. All right? And so that's just when we just have the graph of b to the x. There's no negatives involved. What you should have realized is that if I were to make the coefficient of that whole function, and we're just going to stick with b equals 2 for this example, if I were to make a, which is basically the coefficient of the function, if I were to make a negative, that reflects my line over the x-axis. You can see it right here. It's reflecting vertically over the x-axis. And if I were to take k, which is basically to make the exponent negative, it reflects over the y-axis. This might be more visible if I zoom out, though from reading your descriptions and explanations at the end of that activity, you guys did a really nice job of realizing this. But just again, we see that k is reflecting horizontally over the y-axis. And so the last part of the activity asks you to predict whether or not a function was going to be an exponential growth or an exponential decay function. And basically this is what you should have come up with. You should have said, if I'm starting with a b value that's greater than 1, if I'm starting with a exponential growth function, and I add one reflection, meaning I have one negative, that reflection is going to make it go from an exponential growth to an exponential decay. Now if I have two negatives, for example, if I have a negative in front of my function and in the exponent, having two reflections is going to change it back into a growth. So if we see that process again, b is 2, so we start with exponential growth. If we have one negative, it reflects, and we now have exponential decay. And if we have a second negative, it reflects again, and now we have exponential growth. So essentially, when we have two negatives, two reflections in the problem, it ends up being the same type of exponential function that we started with without any negatives. Now that example was for when b equals 2, right? Or when b is any number greater than 1. But it's the same pattern if we have b as a number less than 1. Let's look at when b is 1/2. And so here we've got both a and k being positive, and we start with an exponential decay function. If we have one negative, meaning one reflection, it's going to go from an exponential decay to exponential growth. You can see here it's going upward on the right side, right? As we move to the right, the function moves upward, which means it's growth. But if we have a second negative, if both a and k are negative, that means we have two reflections, which means it's going to end up the same as what we started with no negatives. It ends up as a decay. So if we walk through that process again, here we're starting with a value of b that's less than 1, so we're starting with exponential decay. If we have one reflection coming from one negative, it becomes exponential growth. But when we add a second reflection, it becomes exponential decay again. And so that was essentially the pattern you should have realized by the end of the activity on Thursday and Friday, and many of you did that. What we're going to be doing today is using these patterns and kind of refining them a little bit more so that they look very similar to what we did last semester with transformations of mother functions. And so we're going to use these patterns to basically graph exponential functions. Alright, so this is the end of the first video, and hopefully we can start up the second video soon. And in that second video, we'll be moving into your notes. So if you guys want to get out your notes, which is the stapled packet you picked up from the back of the room, and we'll pick up there in a second. Alright.